So to put everything together, we can now consider the general instrumental variable regression. And here we have multiple endogenous regressors, and actually we have k of them, right? And we have multiple exogenous or control variables, which are the w's. And if this is an exogenous variable, then it's not correlated with the regression error term, but it's included because it might be correlated with one of the x variable, one or more of them, and we include it because otherwise we would have a greater omitted variable bias, right? So this w, this exogenous variable, is uncorrelated with the regression error term, but it's relevant for explaining a part of the variation in y. So the beta here, it's different from 0, and it's correlated with one of the x variables. So if we exclude this exogenous variable, then we would bias our estimates on these x variables, which are the ones we care about even more. Okay, so remember that we are interested in accurately estimating the causal effect of the x variables, the endogenous variables, on y. Okay, so and in this general framework we also have m instruments. So we have m instruments, and these instruments, they are included in the model because we are suffering in this first regression, regression 10, or equation 10, we are suffering from omitted variable bias because the x variables, they are endogenous, which means that they are correlated with the regression error term, and this means that they are correlated with an omitted variable. And we try to alleviate that by using the instrumental variable regression. So how many estimates, how many instruments do we need in order to obtain consistent estimates of the causal effect of the endogenous variables on the y variable? We need at least as many instrumental variables, m, as we have endogenous variables, k. So if we have more, if we have more instrumental variables than we have endogenous variables, then we say that the model is over-identified. And if we are in this position, then we can actually use the t-test to check whether or not the instrumental variables are in fact exogenous. If they are exogenous, we can continue with our analysis, but if we find that they are not exogenous but endogenous, which means that they are correlated with the error term, then we cannot use them in the instrumental variable regression. If we have just as many instrumental variables as we have endogenous variables, then we say that the model is exactly identified, or just identified. In this case, we can continue with our instrumental variable regression, but we cannot perform the J-test. So we have to rely on our logic and our knowledge of the field to say that the instrumental variable is exogenous or not. And if we have more endogenous variables than instrumental variables, then we cannot implement instrumental variable regression. So what are the steps in the general instrumental variable model? So if we have k endogenous variables and we have m instrumental variables and we have r either exogenous variables or control variables, then we perform one regression per endogenous variable because we want to obtain the x hats. And we regress each and every endogenous variable on the instrumental variables and the control or exogenous variables. And we use the instrumental variables and the exogenous or control variables for explaining each and every x or endogenous variables to obtain the exogenous part of the variation in the endogenous variable. So this x hat should now only contain the exogenous part of x, which means that the estimate we get when we regress y on these estimated values, these fitted values of x, plus the exogenous or control variables, then we should get unbiased estimates of these slopes. Two of the most important requirements for the validity of our instrumental variable regression is that there is relevance and exogeneity. So if we take relevance first, then there should be no perfect multicollinearity in the second stage population regression, which means that the constant term, this is just constant, and the exogenous part of the endogenous variables and the control or exogenous variables, they should not be perfectly multicollinear. And what does that mean? It means that if they are perfectly multicollinear, then you could express one or more of these variables as a linear combination of one or more of the other variables. So for example, if x1 hat and xk hat were just the negatives of each other, so when x1 is equal to 5, then xk is equal to, for example, negative 5, to take a simple example, then these exhibit perfect multicollinearity. So you should not be able to express any one of these variables, including the constant term, as a combination of the other variables. And the second requirement is that the instruments, the z's, they should be uncorrelated with the error term. And we have seen that if you find an instrument which is relevant for explaining the x, but it might be correlated with the error term, then you can add a control variable to make the instrumental variable exogenous. So one really important requirement is that the covariance between each and every of the instruments with the population regression error should be 0.